13, so we were just doing problem number 12. If we read problem number 13, determine whether or not the following vectors are coplanar. If vectors are coplanar, that means they lie in the same plane. Any two vectors always lie in a plane. You pick any two vectors, you always can form a plane that contains those two vectors. But you add a third vector and you get a box, or you get, they all lie in the same plane. So if they do lie in the same plane, what would be the volume of their box? 0, because the box would not have any height to it. You're missing that third dimension. You're missing the height of it. So if you find the scalar triple and it equals 0, that tells you that the vectors are coplanar. So if we take the vectors given in 13 and see what happens when we try to find our scalar triple, we'll see if we get 0 or not. Okay, so pick any two of them and cross them. So I'm going to cross 1, 5, negative 2 with 3, minus 1, 0. Okay, so getting the I will have 0, minus 2, because negative 2 times negative 1 is positive, but you subtract that second product. And then for J, we'll get minus 1, minus 15. And then for K, we'll get minus, oh, sorry, that was K. So J is 0, minus 6, but it'll be plus 6. 0, yeah. And then minus 1, minus 15 is our K. So minus 2, minus 6 for the J, and then negative 16 for the K. And that negative makes negative. All right, so then we want to dot it with 5, 9, negative 4. We get negative 10, minus 54, plus 64. And what's negative 10 minus 54? Well, negative 64, so when we add it, we get 0. So that means that all the vectors